stuff. Okay, so just to remind you, right, when we talk about systems, and I say that, I mean like anything where you've got two equations, two or more, obviously, you know, however many variables you have to solve for is how many equations you technically need. If I have 3 variables to solve for, I need 3 equations. For what we're looking at right now, since we're just doing 2 variables, everything's going to have 2 equations with it. So something like that, okay? That would be your basic system. Okay, now, you're doing technically 2 sections today, but you're doing pretty much the same way. The first one's going to deal with any kind of system that is not linear, and then the next one will be linear. And the reason it's set up that way is because what we'll do on the next day you're in here. But the next day you're in here, we'll be doing systems of linear equations, just as moving to 3 variables, and we'll go through the different ways to solve those out. Okay. Now, for the nonlinear equations, ones with like squares in them or square roots or anything, there's basically 2 ways you guys should probably go about it. I would suggest you not try and do substitution method with nonlinear systems. It usually causes more confusion than it's worth. So with ones like this, like if you had a nonlinear one, which that would be, I would probably suggest you do the elimination method or your combination method. Where you multiply something by a specific number and add them together so that things cancel out, that kind of thing. Okay. So for the stuff that's in the first section, that's what I would suggest you do. Okay. We'll do a couple of them, and I'm going to do one with the graphics, because there's some of these you are going to have to do with graphics, with the nonlinear one. Okay? So, first thing we'll do is the elimination. Okay? And that's going to be the system that we're doing. Okay? You would have done it, yeah, this would have been algebra 2, because it's not linear. Linear deals with, algebra 1 deals with strictly linear.
You can add them together and stuff.
Yeah, this is where you would eliminate one of the things. Now look, the elimination, guys, with nonlinear systems, it's only going to work if you have 2 variables, okay, and they're like exactly the same, okay, 2 terms. So here I've got a term that's an x squared and a term that's a y, so I'm okay with it. The next one we do is going to have an x squared and an x and a y, so then I'm not going to be able to necessarily do the elimination with simply 2 equations. Okay, in that case we'll do the graph. Yeah.
So we're done with logs completely?
No, they'll always be there. The exponential equation will still pop up. But here's the thing, if I'm doing this, right, and by elimination I said, right, that's where you multiply one or both of the equations by a specific number to cancel something out. What do you think I would do? Like, give me a suggestion.
Solve it for y and then plug that one into the y.
Wait, how do I solve for y then?
Alright, that's all. Well, make it y equals. So take the subtract by 5.
Wait, what are you saying? What are you saying?
Multiply the second thing by -2.
Multiply this by -2?
And that's it. No, I lied. Yeah.
Wait, that's fine. And the top by what? 7. Okay. Remember whatever's in front. In this case, if we're doing it this way, we're getting rid of the y. But that's fine. It doesn't matter which one we get rid of.
Wait, why do you how do you know the negative? You need a y.
Remember, they have to have opposite signs, right? Because when I add them together, I want it to eliminate.
Okay.
Be gone. Be gone. So this is going to become, right, 21.
21 squared.
Y equals 26 times 7.
Come
on.
What is it?
Yeah. Then I got negative 10x squared minus 14y equals -6. Right? And then you just add them together. Right? That goes away when you add it. That's 11 x squared with 182 minus 6. divided by 11. What is it? 16. And then the root of that, you get. You get
2.
But here's the thing, it's plus or minus 4. Just the only thing you have to remember with that, regardless of when I plug it back in, guys, if I plug in the negative or positive, it's going to give me the same answer. It's just when you write it out, you've got 2 coordinates for your answer. You can have one that has a 4 and one that has a negative. The y value is not going to change. The y value is exactly the same. So now, once you get here, does it matter where I plug it in? No. So we'll just do the top one. That's the number. Right, 36.
Wow, that's what I got.
Yeah, what's 16 times 3? 48. 26 minus 48. Y is. So when you write your answers here, guys, your answers would be the coordinates 4, negative 11, and negative 4, negative 11. That would be your full solution. Okay? All right, so now that's only, but like I said, that's only going to work if you've got, for us right now, we're just working with 2 variables. Okay, 2 equations. So that would mean this whole elimination thing, or even if you wanted to do the substitution, like solving the y and plugging it back in, it causes more problems. That would have caused more problems. Okay, you got the exact same answer. That's fine. Whatever you're comfortable with. Now, if you've got something like this one, okay, this is the other method. This is the graphic. If I saw something like this and I said, that's my system, these 2 equations, I'm going to solve for x and y. Like I would know right away, I really can't do substitution. I mean elimination. I could do substitution, but again, if I plug this into y, like if I did substitution, it would be me taking this entire thing, plugging it in here, so I'm squaring that entire thing. It's kind of a pain. So with problems like this, what I do is I suggest you just go ahead and go to the calculator and graph. And just do it like you would have done in the last chapter, where you graph both and then just find the intersection. Okay? The thing you've got to remember is when you're graphing these, right, your calculator puts it in as y equals. So you have to actually make the first one as a y equals. And if I change that top one to y equals, it's going to become 17 minus x squared. So y is plus or minus 17 minus x squared. Because it's a circle, so the plus or minus on your calculator is given. So when you actually graph this out, now for this case, I'm not going to have to actually do the plus or minus because it wouldn't hit the negative portion of it. Just so that I've looked at the graph. But if you saw that this graph right here went far enough down, then you would want to plot in 3 equations. You would be graphing that equation, this equation, so it's 1, 2, and then that one, technically. Okay? Yeah, when you do plus or minus, it just splits into 2. Okay? That's how, if you ever did circles, usually, on a graphing calculator, you do like a plus or minus thing. So, the way this would look, guys, is y equals x squared. Okay, now here's what I was saying is, if I graph just those 2 and look at it, like I can already tell there's no point in me graphing the negative portion of it, because the negative part of this one, the negative square root of 17 minus x squared, would just add this part to it. The other graph is never going to cross that part of it, so I don't really care about it. If this parabola went far enough down, or if I had a graph that passed it, then I would want to do it. I don't need to. Okay, you can if you want. Okay, just remember, you go second trace, right? That's your calculation part of the graph. Go to the intersect. You've only got two curves, guys. The first curve, second curve, you can just enter on. In this case, since there's 2 points of intersection, right? There's one here, there's one here. Those are both my solutions, right? Because the solution to a system is a coordinate where the two cross. Then you would just have to make sure you're cursoring over closer to it. So pressing left or right until you get close to the intersection. So if I'm choosing this one, I would just move the guess to close to it and hit enter. It should be 1-4. And then you would just repeat that whole process again. You would go back into the calculator menu, the second trace, intersect. You've only got two graphs, the first curve, second curve, doesn't matter. Now if I want the other point, I just got to move the little cursor thing over to the other intersection. So there's my other solution. So it's negative 2.75 and 3.07. So like for this system that's up there, my solutions for that system would be 1-4, because that's one intersection, and then negative 2.75, 3.07. Okay? Now, and again, like I said, the reason I knew that I would want to do it with graphing, right, is because I saw that I had something other than two kind of terms there that had variables on it. I've got three. I've got an x squared, an x, and a y squared, so I would turn to graphing for that one. Okay? Now, outside of that, like for that first section, guys, you should be able to cover majority of them either with graphing or the linear combination. You can graph all of them if you want. It doesn't matter. Because all you're going to be doing is solving. Okay? This one I would. You substitute this in.
I know enough for this one.
I don't care how you do it. Okay, now guys, hey, the rest of it is all the linear equation stuff. Just to kind of remind you of one thing, because with this section, the second one, the one where you just deal with linear equations, there's probably going to be some questions where they're going to say, here's the system, don't solve it, but just tell me how many possible solutions there are, that kind of thing. So just to remind you of what those are, okay? Remember, your possible solutions are either one solution, and that's simply if you've got two lines that have different slopes, all right? No solutions, right? That's same slopes but different y-intercepts. That means they're parallel lines. Or you could have infinitely many solutions, right? And that's basically the exact same line. All right? So if you've got that question there where it's not actually saying, just make sure you read the directions, because some of these are not going to say solve. They're just going to say how many possible solutions. All right? So just got to keep this in mind. This is nothing other than like algebra 1 stuff, okay, going through this. So it's just a matter of remembering different slopes, create an intersection, same slopes, different y-intercepts, are parallel lines, they're never going to cross, therefore no solution. And then the infinitely many would just mean they're on top of each other, but they're the exact same line. Okay, now we'll go through like one or two. I got two up there, we'll probably just do one of them. All right. Do you want me to do substitution on the one we do? Because we haven't done substitution yet. Just to go through it.
Yes, that's the one where
For
yes,
you,
mine, yes.
you like that one?
Yes,
okay,
thank
we'll
you.
do that one. Just keep it.
Okay, thank you.
Okay?
Okay.
Perfect. Can I go past this guy?
No.
Oh,
Yes.
God.
I'm on the last
Come
one.
on.
Give me more.
Alright. Okay, so guys, here's your option. Left or right? Which one should I do? Left. Okay.
Yes.
So we'll do the one on the left. Alright. Even though I know the other one has no solutions to it. Okay, so we'll do. Jay, do you want to do substitution, right?
Yes, I do.
Okay. Tell me what to do then. What do I do? Dave, come on.
Oh, okay.
What do we do?
You're gonna, I want to do the top one to solve it for y. So
Okay.
just plug it in. Well, actually, let's see. Hold on.
That would be the good route, yes.
Yeah, okay. Then you're going to subtract 2x.
Okay, so that correct?
Yes. All right, now you're going to do 3x plus 4 times, and then you're going to plug in that y up there, the negative 2x plus 1.
Hold on. I know what you're saying. 2x plus 1 right there, right?
There you go. Equals 14. Great. Now you're going to
Thank you. I'm
now
glad.
you're going to distribute. So it'll be negative 8x plus 4. Okay, good job.
Then what?
Now you're gonna put the x terms together, so it'll be negative 5x plus 4.
I know. Can I go to there? Is that okay?
Oh, too fast. Okay.
Is that okay?
Divide by negative 5.
Can I get there?
Yeah.
Then what? Where does this go?
Circle it. Oh, all right.
Circle it. Okay, fine. Then where's it go?
So you can get it circled.
Now.
Right there?
Yep. Right there.
Come on, Dave. Good luck.
Oh, okay. So plug it in. Good job.
So you get y equals.
Yeah.
Yeah.